Well, good afternoon, everybody. Excuse me. I'm sorry I can't be there in person to introduce this topic to you today, but we'll do the best we can with a little video and some advice. So, exercise 28 has a really long and difficult-looking title: quadratic, absolute value, and rational inequalities. So, what we're going to be dealing with here is inequality statements. Now, we've dealt with them before, and I'll just show you. Let's have a quick example. We've dealt with, y being less than something like 3x plus 5. Okay. Now, this is called a linear inequality. Like so. Okay. And we've even graphed something, then we might do greater than negative 2x minus 4. And we might graph that system and shade an area. And we did that on the midterm. Now, what we're going to be doing today is taking a look at quadratic inequalities. We might be able to get to the other two, but I want to start with quadratic inequalities. Okay, so let me show you what one looks like. Here we have a quadratic inequality. Now, this is the first question, and I've just copied it right out of the cumulative exercises. This expression here is just a quadratic. It's not the inequality. Okay, this is a quadratic equation, because it has the equal sign. See? Quadratic equation. Now what we're going to do is I want to start with giving you a graph of this, okay? And then we're going to take a look at what these are, and of course these are the quadratic inequalities. Like so, because of the greater than or equal to sign and the less than or equal to sign. All right. So first of all, let's sketch the graph. So I did this ahead of time, and of course this is y equals x squared plus 2x minus 3. Okay. So that is the graph of that. Now, let's consider what happens when x squared plus 2x minus 3, and just forgive me here, let me flip back, yes, is greater than or equal to 0. Let's think about where that is, okay? Now, you'll notice that there's no y here in this expression. There's no y. And that's because we're concerning ourselves only with the x values. Okay? Only with the x values. So, where, then, is this true? Well, what I'm going to do is I'm going to use a test point as we did before. So let me put 0 in, and we'll square it. And we're going to add 2 times 0, and we're going to subtract 3. Now, let me label that as test point 0. Actually, I don't want 0, comma 0. I want a test point x equals 0. Now, the question is this true? So, of course, we have 0 minus 3, which is not greater than or equal to 0. So we know that this point is not part of this quadratic inequality. So what we want to do is, if we had a number line, we would shade this and this, because all of these x values would satisfy the quadratic inequality right here. Okay. Now, just to show you, or just to sort of as a point of interest, let's pick a new test point, one that we've highlighted. So in this case, I'm going to pick 4. I'm going to pick the test point x equals 4. So we have 4 squared plus 2 times 4 minus 3. And, excuse me, we have 16 plus 8 minus 3. That gives me 21. And it is definitely greater than or equal to 0. So we know that all of these points that have been highlighted are part of the quadratic inequality listed right here. So, how do we state our answer? Well, what we can do is we can use interval notation, and we can say that sorry, there's a better way to do this. Let's go back and factor this. So we can say that we need 2 numbers that multiply to -3 but add to +2. So that's going to be x plus 3 times x minus 1, and that's going to equal 0. And so we quickly get our intercepts here. This is going to be 1, and this is going to be -3. Now keep in mind, just remember, I'm only dealing with the x-axis, okay, because in the quadratic inequality there was no y. Okay, so we can say that x has to be less than or equal to -3 or greater than or equal to 1, just like that. That's one way of stating your answer. Another way is to use interval notation. Now, of course, we got this answer because we factored. Okay, we factored the equation, and that's how we arrived at our answer. Now, using interval notation, we might say -infinity to -3 and use a square bracket. Joined with, that's what this means, or union, and then we can write 1 to +infinity like so. Okay, now in the answer book you'll see the people that did the answer key, they've used the curly brackets to state their answers, but this will certainly work. So that's how we want to state our answer, and we get it by factoring. So if we were going to list some steps, let me clean up this page a little bit. You want to sketch if asked. And I find a sketch helps just because it gives me sort of a visual reference, and sometimes even just a number line is helpful in working with these. Okay, so even if you just use the number line to diagram your answer out, that's possible. Then we want to determine the roots. And then from the roots, you can use test points, either inside the roots or outside the roots. Now, just to explain what I mean by that, you'll notice back here, my test point here actually was 0. And when 0 wasn't true, I knew I needed outside of the quadratic. Okay, so then I used determine the roots to figure out where to set my limits here, like this. Okay, so that's why I've sort of reordered these steps here. I do want you to determine the roots, and then you use test points between the roots to determine the region. Okay? So, again, sketch if asked, even if it's just a number line. Determine the roots, then use test points between the roots to determine the region included, and then state your answer. Now, with the absolute value and rational inequalities, the process will be very similar, but I think I'm going to hold up there and leave that be for now. Because if you get this and you understand this fairly well, the other two are easier. They're quicker to understand. If we rush this one and you're uncertain about what's going on, then the other two aren't necessarily as easy. So, today's assignment, what I'd like you to do is make sure that you get through, oops, too far. In exercise 28 here, what I'd like you to do is make sure that you do the quadratic inequalities today. So that's questions 1, 2, and 3. I want you to work on some of the other questions. You see 4 is a triangle type problem. We know how to do 5. Now 6 is the beginning of our rational inequalities. So for today, you can skip over that. And 7 and 8 are still rational inequalities. And just as a highlight here, you can see why they're called rational. They're stated as a fraction, okay? And then they are greater than or less than equal to 0. So those are the rational inequalities. And then we have some absolute value inequalities. That's numbers 10 and 11 and 12. Okay? But then, of course, we can go on with questions 13 and 14, like so. Okay? 15 and 16 as well. Probably down to 20. Or is 16 the last one? 16 is the last one. You can certainly pick up with exercise 29, and I will probably have something more for you on Wednesday, and we'll see each other again on Thursday. Good luck.